Hello everyone, I'm Silent Death, and welcome back to Stationeers No Mining Challenge. Today we have something pretty amazing planned. Probably the biggest quality of life improvement that we've done yet this episode, or this season. But first, we've replaced the silo with a vending machine because silos apparently get bugged if you put seeds in them. That's just something that happens in the current version of the game. Next up, our little greenhouse area here is getting heated up a lot faster than I was expecting. It's already stopped because it's gotten too hot. So what we're going to do is add a little bit of cooling. And we're going to do that within a passive action. By sticking just that and a few pipes. We'll start with 2 or 3. We'll say 3. You can always add or remove some. And we're going to go with a pipe radiators. And let's see if this is working correctly, or if we have to move them out so they're not clipping into the room. They're radiating and convecting. So we'll see if that cools the room out, or cools the room enough. That's more than a cooler, a wall cooler, total. Because wall coolers are 1,000, and that's 3 times 300 and something. Okay. One more thing we want to do before we get started in today's episode is we're going to come down here. And we're going to update the script for this guy. There's one thing that I want to change. And that is, when we turn these on, all the sorters are off. So if there's already stuff in here, we have to press the button for it to turn on the machines and turn on the sorters. So I want it to detect when a machine gets turned on and then turn on all the sorters. Import. So we're going to do that somewhere around in here. We already have a check to see if they're on, so we can change this area. And that is what we've done. We've just changed this jump to sorters on. And this turns on the sorters and the stacker and jumps to main. Nothing special. That was pretty easy. And everybody's on. And everybody's off. Excellent. Now then, let's head back out here. Over here somewhere, there's the entrance, so probably right around in here. Yeah, I think that's right. We'll start by spray painting some chutes khaki. And we're going to add a vending machine, our vending machine here. And this is going to hold a bunch of stuff. what we're going to do today is create a keep in stock system that keeps, our commonly used items in stock in this vending machine. I'm thinking things like wires and pipes and things like that. So we want to have a composite rollover door. For some reason this cannot be placed. Is there a wall there? There is not. Can these only be placed on one if there's nothing behind it? They can. Okay, that does not work for me. How would we do that? We would have to rip out the wall, and that would flood this whole area. That's not great. Maybe we won't have a composite rollover cover. We'll place it here, and when we upgrade stuff, when we pressurize this room, then we'll replace it with a composite wall thing. Turn this on. While we can still reach it, okay. So we don't have the stuff we need to put there anyway. Now, first we want to do is we want to connect this to our stuff over there. We also want a chute that comes up here for us to manually put stuff in, which I think we need a power chute for that. Powered. And we'll just kind of cram this in here. A chute bin. I kind of want it, for flush. I think there's fine. What we'll do is we'll come down underneath here and hook these up. That's a little bit in the way. Okay, that should take care of that. Now then this will go, we'll just go straight down and over. Underneath the vending machine. One place. It doesn't want to place. Alright, first let's hook you up like this. Maybe this will work better. And we're out of chutes. Okay, let me go grab those. And now that that's hooked up, we want to seal this off first, so we don't accidentally vent our room. That looks better. And we want to spray paint this, which didn't actually spray paint. Okay. And we have the circuits here. We're going to have 2 of them. And we'll run the power up in the middle. And then we can just connect to this already existing thing. Since they're going to be on the same circuit. Okay, that wasn't hard. And we'll figure out what color to paint those later. Now we need to go inside and hook this up to the stuff inside. Okay, so just past this guy, we're going to add a sorter. And we're going to say you should probably be white. Yes, you should be white. I'll add that later. First, we need to remember which way things go. Now, we'll know from up there that the filter stuff goes in this slot. So that is going to be the brown slot, or the khaki slot. And I can wire that up later. Get this stuff out of the way. So we now need to come and hook this up to this. And I'm just going to do that off camera. You don't need to see me lay shoots. Okay. I've connected the chutes. Wasn't very difficult. Now, I removed the radiators from there because 3 was a bit much. It drained all of our power trying to heat it back up. We're going to go here and we'll hook this up. And we're going to give you a name. Product sorter. Then let's head out over there. We need some elevator music for these airlocks, don't we? That would be kind of perfect. We just need some music in the game. Outside of the main menu. Alright. You need to power that, which you can do later. It's not going to be programmed, so it doesn't really matter. We do need to power this. And that does matter. And I think we're going to have to go underground, or under the frame. That does seem like the only way that we can get both of these. Then we have to go all the way down. Which, wow, that's going to be difficult. We're falling. Okay, back to mining this out. Okay, now I can reach. A little inconvenient that you can't run. Oh, I guess you can. You can't run through the straight ones. You can run through the curved ones, apparently. And I left my drill on. Okay, so that's wired up with both those. I'll weld that up in a moment. But first, we're going to have these two, which are going to talk to each other. And I'm not sure which is going to be which. I guess this will be the first one. But the first thing we want to do is add a list of items that we want to keep in stock and the devices in the register. So let me type all that crap in. Okay, so we have alias and defabricate IC. This chip is just going to be checking to see what's in the vending machine, and then it'll hand it off to another chip if we need to actually craft something. Then we have the stacker and the sorter, and then the vending machine. Then registers for the stack pointer, on and off, ingots, index, slight item hash, the stack hash, stacks, fabricator, fab hash, ingot count, and produced. Then we have hashes for the sorter, the tools, tool manufacturer, lathe, electric printer, pipe bender, and I did include the hash for the fabricator, but we probably won't be using it. I've just stuck it in here in case I decide to expand this at some point and don't have to look it up. Since I was already looking stuff up, I went and did it. And this is the max slots for the vending machine. And then we have the knit. So we're setting the setting to 0, the setting of the housing to 0, and then I'm pushing all the values. So cable coil, heavy cable coil. You'll note I default to 1 stack of an item, but if I want more than 1 stack, I push the stack amount right after the hash. And then, you know, pipe is slated, liquid pipe, blah, 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 all that stuff. So that's most of the things. And the very last item is going to need to have a whatchamacallit? A stack count, because of how I plan on writing this. And at the very end of the knit, we're saving the stack pointer. After all that stuff gets pushed in, we save how much stuff we have, basically. We'll use that for later. We just need to keep track of it. Now we need to loop through this list and the vending machine to see if we have the stuff that we want. Let's start with that. Okay, here we go. So we have start here. First thing we do is set the stack pointer to the bottom of the stack, which, you know, not if the stack is empty because that's 0, but the first item or the last item, depending on how you look at it, the first item that was pushed on the stack, basically. Then we have check stop label here that loops down here, so this whole thing is a big loop. Then we peek at the first item to get the hash, which is the number that we pushed in. Then we add 1 to the stack, and we peek at that, which is our stacks. And if that number is less than 10, if it's less than 10 and greater than 0, we have a defined stack. But basically, I'm supporting stacks between 1 and 9. We can have up to 9 stacks requested. Anything more than that, it assumes it's a hash. Then right here, if both of those are the case, if it's greater than 0 and less than 10, and we branch past this line and this line. Then we move 1 into the stack thing. If it's not, so if the stack's not defined, this is where we're setting the default stack size of 1. And then we will jump past this line here, which is where we're adding a stack pointer to 1. Then we set the index, the first storage slot, -1. And we're going to check the storage, which we haven't defined yet. And if not enough stacks, we will jump to fabricate. And right here, is the check for the end of the stack. We go back to the beginning if we've gone through the whole list. And that's this line right here. And then check stop. Back to loop. So the next thing we need to do is the check storage, which just means looping through all of the slots, all of the we're ignoring the import and export. We're going from 2 to 101. And just see if it's what we want. And now for check storage. So if you remember right here, we set this to 1, but the actual storage slot starts at 2. So the first thing we do is we're adding 1 to it, and that'll be part of this loop here from here to there. Then note that we used an AL here so that we have a return address. So if the index is greater than the max slots, we return. That keeps us from accidentally overflowing and throwing errors and all that stuff. Then we will load the slot item hash from the vending machine at the slot of our index through loading the occupant hash. Then, if this is not equal to the desired hash, which we set way up here, we keep going to check storage. If it is equal, then we remove or we subtract 1 from our stacks, which is the number of stacks of the item that we want. I'm not bothering counting to see if they're full stacks or anything. I'm just saying if it has any amount, that's considered a full stack. Because I'm not going to bother with the stacker to combine stacks and all that. That's just too much hassle for me. I don't think it's worth it. Especially when I'm going to be taking stuff out and using part of a stack and then putting it back in. That would be, too much. Yeah, not doing that. Okay, so there's that, and if this is less than or equal to 0, if our stacks is less than or equal to 0, basically if we have enough stacks, then we return, and otherwise we keep searching. That's a pretty easy function right there. And now we have to do the fabricate function. Alright, here's the fabricate function. So this makes our stacks of our stack hash. So we're going to set the setting of the housing of the fabricate IC to the stack hash. Then it needs to know how many stacks we need to bake. So we'll turn it on, and we set our setting to stack hash. So we're setting both the housings to stack hash. Then we're waiting for the stack hash to be read. So what this is going to do is it will, once it reads the stack hash, it's going to set its setting to 0. And if it's not 0, it's going to keep looping while we wait. Then once the other IC chip sets its setting to 0, then we tell it how many stacks we want. And here, we're waiting for production. So while the IC or the second IC chip is running, it's going to keep the number on its setting until it gets finished producing. And we're just going to use the same exact loop here for reading the setting for production. Now, once we finish production, once we reached here, we finish production. So we just reset the setting and we go to check stock. go back to the thing. And that's this whole script. So let's go on to the second one. Okay, we have set up here for the devices. We have the ingot IC, that's the one inside the automated ingot delivery IC. Then we have the stacker, the product sorter, and the vending machine. That does mean we don't have enough screws to do all the fabricators. So we're having to use hashes, and I'll just copy these from the last script, which we did not actually need them for, but whatever. Then we have the stack pointer on off. I copied these two mostly. Stacks, fab hash, item count, and are produced. I think those are the only two that I might have added. Then down here, we're initializing. We set the setting to 0. Then for start, we have a loop here that goes from here to here. Not a very big loop. It sleeps 1, loads the product task from setting. If that's 0, then it loops. So if it doesn't have anything written, it just loops and waits. Then if that is not 0, then it lets the other script know that we've read the hash by setting the setting to 0, setting the housing setting to 0. Then we do the same thing, except for we're reading the stack amount. So this is the comparison to, or the complement to the last two things that we read in the last script. So sleep, read the setting, then if it equals 0, loop. If it doesn't equal 0, we wait for idle fabs. Because the important thing we need to remember is that we might actually be manually producing something. So then we want it to wait until we're done. And that is what we're going to write next. Okay, so wait for idle fabs. Now I don't technically need the jump here, but I want it. So we're setting the database setting to wait for idle fabs. This is a debug thing. It's very important when you write a script that does this automatic production, you make sure that you're doing it right. Because you don't want to accidentally be producing, I don't know, 1,000 plastic sheets or something, whatever. You don't want to use up all your resources accidentally producing the wrong thing. So having a lot of debug information so that you can check the thing in the IC tools thing. It's weird. So you can check the things in the IC simulator on the Stationeers website, and make sure that your thing runs before you actually check it in game, or just not put very much stuff or very many ingots in your machines until you're absolutely certain that it works. So wait for idle fab. We set the setting to, this is basically the equivalent of setting it to RA, which I could have done, but since we're not returning, I did not. And if you don't know, label like this is just an alias for the line number. So that tells us where this is. Then we sleep. We load batch. We're checking to see if it's producing stuff by looking to see if the sorters are on. So if it's basically just checking to see if any sorter is on. And we need to make sure that this whole thing is an isolated network when we're doing this, which it's not right now, but it is the only thing that has the sorters on it right now. Eventually we'll split up the networks a little bit more. We already have this split up, and we'll split up others when we do more building. But right now it's kind of merged together with our trading area. But it doesn't matter because that doesn't have any sorters on it. So if these sorters are on, it keeps looping. And if they're not on, then it goes on to the next line. And that is where we're actually going to be producing stuff. And here we're doing the same debug information. Sleep. Then we will jump to find the fab, which we'll go on to later. Then we're going to load batch our fab hash, recipe hash, maximum. So this is going to come from this. So maybe let's look at the fab hash first. Because the fab, this is what this will do is set this value to whatever item produces what we want. So let's look at fab hash first. Now we're setting the setting to the find fab. And we're saving the return address because we're going to be making some other calls. So we want to make sure that we keep that saved. Then we will move the hash into our fab hash. So we're setting our fab hash equal to the hash pipe vendor and then the various hashes of the thing. And then we have this number here, which corresponds to the button number. When we press the button, if you remember, when we came in here, and when we push a button, that corresponds to the screw that the pipe that the various devices are on. So button 1, which is here, corresponds to the hydraulic pipe bender. And that's where that number comes from. Okay, now let's look at the find fab function. So what this does is it sets the fab hash that we set up here, the recipe hash of that fab hash, to the production hash. Then it waits. I could use a yield, but I'm using a sleep 1 just to be sure. A little extra wait. And then we're loading that. We're loading the recipe hash from fab. Basically, we're trying to set the production hash. We're trying to set the recipe hash to the production hash. And then we're seeing if it actually set. Because if it can't make the item, it will not set it. And if it can make the item, it will. And if you remember, we have these already sorted in the priority that we want things to be made. I think these might be backwards. Yes, these are backwards. That's the way that's supposed to go. All right, so, and then if they're not equal, so if it could not set the recipe hash of this fab to the production hash, it will return. And if it could, it jumps to RA, which returns to the caller of this function, which is up here. And then does that for each fab. So let's go, we were talking about this. So now we are loading the recipe hash from fab. And we're adding a safety check here. Basically doing the same thing. If it did not get set properly for some reason, whatever that reason might be, I don't know, power shut off or something, and it screws something up, we have no idea. This is just, you know, because we're using up resources, we want to make it doubly sure that everything is doing what we want. So we're adding just this extra little check here, which is basically the same thing that we've done down here. Then we set our ingots, our ingot IC, to our fabs, which is the index number down here. So we're basically simulating pressing a button. that is what that does. And where were we? Right here. Then we're setting our setting to the production hash. And we're waiting for the ingots. So we're setting our database setting to wait for ingots, which, you know, that means this line doesn't really do anything, but I'm leaving it in anyway. Then we sleep one, the standard wait that we're using in this whole script, and we're loading the setting of our ingots IC. We're waiting for that to set itself to 0 until it's done. If it's not equal to 0, then we loop. If it is 0, it means it's done. So we clear the memory of the fabricator, the sorter, the stacker, the vending machine, and then we start producing by activating the fabricator. Now, more debug messages. Wait command. We're going to wait for the first item to be produced right here. The reason for this is we need to know how the stack size of the item, and we get that from reading the slot information, reading max quantity from the slots. So we may want to turn off the stacker before this. I'm not sure. This should theoretically be okay, given how fast things move. But we could theoretically turn off the stacker thing here. And I think, you know, maybe that's a good idea. Set the stacker on to 0. And then we'll turn it back on there. Make sure we have a yield. This is just for things that only have a stack size of 1. We want it to make sure that it gets a chance to read them. It usually takes longer than half a second for stuff to go through the slots, but I'm just being doubly sure. Make sure that we didn't go across our limit. No, we're fine. Okay, we were right here. So we're loading the occupant hash of the item in the stacker. In the first slot, or in the 0th slot of the stacker, which is the import slot. Then, if for some reason the item in the import slot of the stacker is not the item that we're making, then we keep looping to up here. There's some rare chance that there might be something that got in the chutes that was left over from when we were crafting before, and we just didn't take it out. We have the ingot sorter, the automatic ingot delivery script is supposed to clear the stacker, but there's a chance that that could, for some reason, not work. So we're doing a little check here. Then we read the max quantity, which tells us how many items are in a stack for that particular item. Then we multiply the number of items in a stack times the amount of stacks that we want. And then we're turning back on the stacker. We're waiting for them to produce the amount of items that we want. So we're doing the same debug message. We have the wait command because it's a loop. And we are loading batch. We're loading the export count of the fabricator. And we're putting that in our produced. If our produced is less than the amount we want, we loop back to the start. If it is not, we stop producing stuff. Then we're waiting for stuff to move through the chutes. So we're loading the import count of the items in the stacker. And if that's less, did we wait for it to be produced? Did we wait longer? Then we activate the stacker to clear the stacker just to make sure. And then we're waiting for the stuff to get to the vending machine. And again, because this is stacks and not items, we need to check to the stacks and not the item count. So, get the stacker, load the amount of items that have entered the vending machine, and then we wait for production if that does not reach the amount of stacks that we want. If it has, then we clear our setting to let the other script know that we're done. We turn off the fabricator to let the IC ingot script, the automatic ingot delivery script, know that it can turn off all the sorters. Then we turn ourselves off. And we go back to the beginning.
Airtag critical.
So we can load that up, and I'll be right back. Okay, a couple of things that we messed up on. Or we forgot to do, actually. After we cleared the memory, we forgot to set the sorter. So we're going to set the sorter mode to 1, wait. Then we'll set the setting input to the product hash. So we're setting the filter for the sorter. And then we actually start producing. And wait for the item, blah, blah, blah. And when we're done producing, we use setting output to remove the filter. And then, since when you clear all the filters, the sorter mode defaults back to 0, we're going to set the mode back to 1. That way, when we're producing stuff manually, it doesn't get stuck in the vending machine. Also, we need to update our automated IC script, automated ingot script, to take into account this extra sorter that we've stuck on. Let's import this. And I think we'll do it on all on. Or no, we'll do it on all on and sorters on, maybe? So all on. There's the sorter on. Then, oh, we don't have that set, do we? Do we have an extra screw? We do. So, alias the sorter is going to be D5. That works here. Branch if device is not set. The sorter. And we'll go to RA. Then, if the device is set, we will do set sorter mode 1 yield and then return. And that should be everything. We want to do the same 3 lines down in sorters on, wherever that is, up here, or we just turn on the sorters when we manually do that. So let me type that real quick. Okay, that's that much. Export. And next step, I've already dumped how just okay, never mind. I've dumped all the stuff that we had in our storage area into the vending machine of the things that we want to produce. So we're going to give this a test run. Also, even one little radiator was too much cooling for that area. So I'm going to see in the last bit of this episode if we can figure out how to cool that a little bit better. But first, we're a little bit low on power, so I'm going to wait for daylight. Another change we need to make to the ingot script is to increase the delay because it's not having enough time to go through the sorter, so we're going to increase this to 3. That should hopefully do it. I can build a test item. Okay, that did not work because that's not in mode 1. But it did go through. And I don't know why that's not in mode 1. In mode 0, we should have set that up. Did I forget to set it up somewhere? This mode. Oh, I forgot to set the screw. Whoops. Okay, once more with filling. And still not enough to go through. Why not? Mode is 1 though. Import count is greater, so let's bump it up to 5 maybe? Oh, there. You may need a dummy filter for this to work properly. Maybe. Let's turn on you again. No, that is not the problem. Okay, I think it needs a dummy filter. So what we'll do is we'll set it to seeds. So back where we're setting the mode, we're also going to set a filter to, it could really be anything. Ingots would also be good. Ingots would probably be best. Let's set the filter to ingots. That is something that we know that's not going to come through here. And it will also prevent it from accidentally switching back to mode 0 when we remove stuff. Let me type that. Alright, one more time.
Health critical.
Alright, that works. That much is done. Now then it's just time to test the main production script, which I think is still dark. Yes, it is still dark. Alright, it's daylight, and I made sure to save my game, so let's turn this on. I should have hooked up all the screws, and it's already producing something. 1 stack of... I didn't catch that. But we can go inside and see. You're 0. Okay, I have no idea what went on. Something is obviously not working. Unless it produced like one item and it was done that fast. It shouldn't have. You were at 41, 94, 94. Just a second. Okay, so 41 is fabricate. And 94 is to find the fabs. But what's happening is it's getting stuck right here in our double check area. And looping. And I don't know why. Let's go check to see what we're trying to craft. So 212064 something something something. Let me see what that is. Okay, the problem seemed to be that we just need to turn this on before we try setting the recipe. I assumed you could set them when they were off, but apparently not. So if we go over to our script, all this finishes crafting. We will see what we changed. And it's a really small change. Just down here in the find fab function, we turned the fab on and yielded. After the check to see if it did match, where it returns, then if it matches, we turn it on and yield and return. And that's all we had to do. So this is currently producing copper cable, and then it should go onto a heavy copper. So let's look at this inside. Taking a little bit long on this episode. We still have to finish that stuff up there. Okay, that is finished. That is done. We need to go check to see if it produced a full stack, but wait for this to come on. Okay, now it's producing heavy watt wire, which is what we want. Something weird's going on there. Not quite sure what that was. But let's check that and then we'll try to take care of the greenhouse cooling. And here it is, a full stack of wire. Going. Now then, let's run up here. Okay, so this is still heating up. It's not very fast, but it is still heating up. And I asked on Discord, but I did not get an answer to see how much heat a plant produces. I'm sure there's written somewhere. So we're just going to go like this. And I'm going to watch this for a little bit. Okay, it's still going up. We'll watch it for a little bit longer. Alright, that's still going up. It might be the sunlight. I'm not sure. Positive is heating or cooling. Let's check. We can check with this guy over here. I think positive radiation or positive radiant is cooling, right? Yes, because that is cooling. Okay, so it's still cooling. Another thing we could do is we could lower the pressure in this pipe and do some weird stuff. I think it's still going up. 05, 05, 05, 05, 6. Yep, still going up, so we need more pipes. After adding 60 more pipe segments, it is still heating up. So, I don't know. This isn't working. We will need to try to put more gas in here. I think that is our best bet. But that's going to have to happen in the future. We are out of time for this episode. Like if you like, subscribe if you're not. Thanks for watching, and I will see you next time.